Morning, guys. So let's have a recap on what I have talked about last week. Last week, we have talked about pointers. So what's a pointer? Oh, by the way, you are not required to be very good and at pointers. So you just for the previous lecture, for the pointers related lecture, you just need to understand what does pointers means, and when you see pointers in the code, you can know what it is for, what it's doing. So this is the this is the target for the previous lecture on pointers. It's for you to have an understanding of pointers and to be able to understand the code related to pointers. So what's a pointers? Pointers is something very unique to C++. It allows you to manage the memory of your program. So actually pointers is just a variable. It's a special variable. Previously, we introduced many kind of variables, right? Like there are integer, double, float, or long. These are different kind of variables. But then pointers also is a type of variable, but the value it is storing is actually an address, a memory address. So this is what makes pointers so special, because it is storing an address. So by using a pointer, we can manage the memory in our computer. Like we can allocate a memory space for a value, or we can release this memory space and we can store something into this memory space, or we can retrieve some value from this memory address. So these are what pointers can do. And given a variable, how would you be able to get its address? So you use a special symbol. This special symbol is called n%, n. So you write n in front of your variable. This return the address of your variable. So in this case, it returns the address of A. And how you define a pointer. So this is how you define a pointer. The type would be the type of the value that is storing at the memory address. So if your address is storing an integer, so this should be an integer, int, and then star. Star means we are telling the compiler that this is a pointer type. And then name could be any name, your pointer name. It's basically a variable name. It can be anything you like it to be. And then to assign an address to a pointer, we use the equal sign. So you assign an address to a pointer at the left side. And then how you so given a pointer, let's say the pointer is called name, and then this pointer is storing an address, right? What if you want to get the value storing at this address? Let's say there is an integer storing at this address. How you get it? You write star in front of your pointer. So star name retrieve the value storing at this address. And then also, if you want to change the value storing at this address, you want to manipulate the value storing at this name address, you just use the equal sign. So the value at the right side will be assigned to the address pointed by the pointer name. So there's an example over here. first we have defined a variable integer of integer value. So variable A has a value of 10. And then we define a pointer P. How would we know this is a pointer? Because there is a asterisk over here. So this tells the compiler that we define a pointer. And then we want to initialize this pointer. We want to store an address at this pointer. So how to get an address? We use n and then your variable name A. So this gets an address and we assign it to our pointer. So remember, pointer is storing an address, right? So pointer P is storing an address. And then now the pointer is initialized. It's pointed to an address. So this address actually belongs to variable A. And then right now in this address, the value it's storing is 10, right? But using pointer, we actually can manage this address. We can manipulate the data over there. So how can we do so? Let's say you want to update this 10 into X. So we can update it through P. How can we do so? We can assign X into the value storing at this address. So the value storing at the address A is updated now, it's X. So if we print out A right now, it's X, right? If we print out the value storing at P right now, is also X. And if we print out the address storing at P, it will be an address, right? And then if we print out the address of variable A, it's the same as the address storing at P. What does this mean? This means P is pointed to the address of A. So if we manipulate the data at the address through P, it has the same effect of A, right? Because they are pointed to the same address. So that's the idea behind pointers, and we have discussed it in last lecture. And then also last week we introduced something called function. Function is basically it's like main function, but then usually we use main function, right? But then you can write your own function as well. Like you can separate out your code into some other function, right? So, but when we have a function, let's say we have a function show, if we want to pass a value inside, how can we do so? So in this example, we have a main function. Also, we have a show function, right? And now, when we are calling this function to do something, we want to pass in a variable, right? This function is accepting variable x. How can you pass in a function? Usually, you just pass in, so you can pass in directly your variable. So you just pass in x, and the show here will receive an x as well. But then the problem here is, if you manipulate the x inside this function, it doesn't affect the x in the main function. Why is that so? Because this is called pass by value. This is called pass by value. That means when we are passing this x into this function, your compiler, your program will create a copy of this x and pass it inside. So this x actually is storing in another address. It has its own value. It has nothing to do with the previous x at all, right? It's a separate entity. And thus, if you increase or if you manipulate its data, its value, it doesn't affect the x in the main function at all, because they are separate entity. They are storing at different memory space, right? So if you want the manipulation of x here to have an effect on the main from the caller, how can we do so? We can do something called pass by, like pass by pointer, right? If we pass by pointer, just now we already explained what is a pointer, right? Pointer is storing an address, right? And then using this pointer, we can manipulate the value storing at this address, right? So pointer is something suitable for our use case, for our previous use case, where we want to pass in a variable to a function, right? To a function called pass by point in this case. And we want to do something that if we manipulate the value here, we want it to have an effect on the variable in the main function as well, right? In this case, if we have an a, and then we pass in an a into our function, and inside this function, if this function is manipulating a, we want the a in the main function to be updated as well, right? In this case, pointer is something suitable for us, right? So in this case, when we pass in a variable into our function, we can pass in an address to the pointer because the function is accepting a pointer p. So we pass in an address to initialize this pointer. And then this pointer can update the value storing at the address, right? So it updates the value to 10, right? And then after this function is run and completed, it returns back to the third line, cout a. So if you print out a over here, it will be 10. It is not 5, right? Because we change the value of a inside this function. So the a is now 10. This is one of the usage of pointer. So it allows us to change the value of a variable inside the function, and at the same time, the variable inside the main function will be updated as well because they are pointing to the same address. Okay, it's one of the usage of pointer. And also there's something special for an array. So array basically will be converted into a pointer form. So while the compiler is compiling the array, actually change it into the pointer form. So for example, let's say we initialize A to be an array with 10 elements and it's empty right now, right? And then we can assign A to a pointer C. And then we print out C. It will be the address of A. You see here, the special thing is we are not using an A, right? We are not usually for a normal variable, for usual variable, we use an A to get its address right. But then for array, we don't need to write an A. So A itself is enough because an array is actually in pointer form already. So we just need to pass in A. So this A is the address of the array. And this is something special about array. And so we have walked through what we have talked about last week. So we introduced pointers last week, right? And this week we are going to talk about reference. Reference also is something unique in C++. So what is a reference? We can think of reference as an, a replacement name, right? You can think of it as a replacement name as another name. Like an alias name. So a reference is saying that a reference is not an object or entity. It's an alias name for an existing object or entity. So let's look at some example. If we have a variable called number, So this number has a type of integer and its value is 10. And then if you want to refer it with another name, let's say you want to refer it with a name called num. How can we do so? So we can create another variable. So this variable is special. So you see when we declare this variable, we write integer and num. So this n means that this is a reference type variable. And then when we assign it, we have to initialize it with a variable immediately, right? So this line means number is the alias name for num. Num is the alias name for number. And num and number are the same thing. It's just an alias name. So there's a question here. So given a variable called weight, create an alias name called w and output the value of w. So this is probably a question, an exercise in our platform. We'll go through it together later. So what if we declare we declare this reference type variable, but then we didn't initialize it? Is it allowed? It is not allowed. So when you declare this variable, you have to initialize it right away. When you declare this reference type variable, we initialize it right away with another variable. And if you are manipulating the data in the reference variable, if you manipulate the data in num, the value in number will change as well. It will have the latest value as well, because they are actually the same thing. It's just a different name. They are actually the same thing. And then one thing to take note is that when we are creating a reference variable, when we initialize it, it has to be initialized with a variable. You cannot initialize it with a number or with something like a constant. Let's try it by ourselves. Here, integer num equal 10, integer n, and then we print out num. So we print out the number is not. So you see, we have number and we have num. If we print out num is also 10. But if we print out number, it should be 10 as well. Okay, it is 10 as well. If we update the value in num to 5, what will be the value inside number? You can take a guess, but it's actually 5. Yeah, it's 5. And you see, we have to initialize reference with a variable. We cannot initialize it with a constant, right? It's not allowed. If like 100, see, it is not allowed to initialize it with a constant. You have to initialize it with a number. And also, if your number has different type, it's not allowed as well. Okay, so they have to be of the same type. Your variable and your alias has to be the same type. So there is a quiz over here. Which declaration is invalid? If so, assume that the variables are existed. Integer a equal 1.1. This is incorrect because integer are not able to store. Integer type variable is not able to store a floating point number. So this is invalid. This is incorrect. Integer and b equal 2. So we just mentioned it just now. We cannot initialize a reference with a constant. It has to be a variable. So 2 is a constant. So this is invalid. Second one is invalid. How about the third one? A count reference, we initialize it with n. So if n is an integer type variable, then this is valid. If n is not an integer type variable, let's say n is float variable or n is double or long, then this is invalid. But for this case, if you assume that n is also an integer variable, then this is valid. Integer reference. So we declare a reference, but we didn't initialize it. This is invalid. There is another quiz over here. So which one is invalid? We have a equal 10, and then the reference R1 equal to A. Also, we have floating point B equal 0, and then R2 equal to B. So if we assign R2 equal 3.14, this is correct because R2 is a floating point number. So this is valid. If we assign R1 to R2, if you assign R1 to R2, I think this is valid because R1 is actually an integer. So if we assign an integer to a float, it's actually allowed. We can try it by ourselves. Integer a equal 0, R1 equal A. Should be float B equal 0. So if you write R2 equal 3.14, this is allowed, and R2 equal R1. And then we print out, at the end we print out R1 and R2. So this is allowed, you see, because R1 is actually, reference is just an alias name, right? So R1 is actually A. So we are assigning an integer to a float. So this is allowed. When we assign an integer to a floating point number. Oh, A equal to R2. That means we are assigning R2 to A. This is also allowed because we are assigning a floating point number to an integer. So the decimal part will be trimmed, will be removed. Okay, so 2 is also allowed. And R1 equal B. R1 equal to B. That means you are assigning a floating point number to an integer. This is also allowed. So everything above are valid. And then already we introduced pass by value, pass by pointers, and there's another type. It's called pass by reference. This is for when we are working with function. See, okay, so when we are trying to pass a parameters to a function, usually we use pass by value, or maybe we can use something new which we introduced just now. It's called pass by pointers. But other than that, there's an alternative called pass by reference. Let's look at an example. If we have a swap function, what does this swap function do? So given a, an integer a and integer b, this swap function will swap the value inside a and b. So at the end, a gets the value of b, while b get the value of a. This is what swap function does. So when we call this swap function, in order to swap the data between, swap the value between a and b, how can we do so? So we assign a to a temporary variable, and then we assign b to a. So now a gets the value of b, and then we assign this temporary value back to a. Remember, this temporary value has the value of a, right? So b gets the value of a now. So right now, a have the value of b and b have the value of a. So if we look at the complete code, we have an integer main. Inside this main, initialize an integer I with a value of 3, and j we have value of 7. And then we want to swap the value between I and j. So we write a swap function, and we pass in our parameter I and j. So inside our swap function, which we assign the value of b to a, and we assign the value of a to b, right? And as we have discussed this morning, right, the update in a and b would not reflect in the main function, right? It won't affect I and j. So when you print out I and j, there will still be 3 and 7 instead of 7 and 3. We can try to run it by ourselves. So I and j is 3 and 7, and we swap it, and we actually expect it to be 7 and 3 when we print it out after swapping. But then it's still printing out 3 and 7. So this is not our expected behavior. And if we use the pointer method, like this, because we introduced pointer method in the last lecture, right? So we pass in the address of I and j, and we swap, let's say teacher name to the value of a, and then b equal the value of a, wait, a equal the value of b, and b equal to 10. So now if we print out I and j, it will be 7 and 3. Yeah, it will be 7 and 3. That means we actually updated the value inside I and j. So this is passed by pointers. But we can do it by pass by reference as well. So if we pass by reference, team equal a equal b equal team. If we pass by reference, we don't have to use an over here when we're calling the function. We don't have to pass in the address. We pass in the variable itself. Right. If you pass by reference, you see the I and j are updated as well. When we're changing a and b, I and j are updated as well. Why? Because if this is a reference, that means it is actually a and I are actually inside are storing in the same address. They are basically the same thing. Also, B and J are storing at the same address as well. They are basically the same thing. So if we manipulate a data at A and B, the data in I and J will be updated as well. So this is the power of pass by reference. So you see, you have so many tools inside your toolbox now. You have pass by value, you have pass by reference, you have pass by pointers, right? So you can choose which one suits your use case more. And also we have introduced functions, right? So functions is something that you can pull out some of your code and you wrap it inside a function. So this function, the so the usage of function or the why would we use a function is for make is to make our code cleaner. So when some of our code have a lot of duplication, which can be reused, we can wrap it inside a function, right? So we can easily reuse this function, the same code snippet. This is what the function is for. So, so there are some notes over here. If we use pass by reference, it and we change the data of the reference, we change the value inside this reference, it actually change the value that is being passed in, it changed the variable that is being passed in as well. So what is also there is a benefit of it. So it increased the efficiency of our program. So because if we are doing pass by value here, if we are doing pass by the value, our compiler, our program will actually create a copy of I and J. And this copy of I and J is stored in another address. So that means our program have to allocate some extra spaces for this A and B, right? Because they are storing in another address. It's different from the address of I and J. But then if we are using pass by reference instead of pass by value, if you are using pass by reference, A and I, B and J, so A and I are the same thing and B and J are the same thing. They are storing at the same address. That means our program doesn't have to allocate another memory space for, for A and B. So this space and also this increase the performance, increase the efficiency of our code. So that's why when we are passing a parameters inside our function, pass by reference and pass by pointers are actually better. Most of the time is better than pass by as simply pass by value because they have better performance. Also, they are going to introduce something special called a special keyword called constant, CONST, constant. So constant means you are not allowed to change this data. Let's say we define a constant integer a equal to 10. So this variable, this constant is not allowed to be changed. So we can try it by ourselves. If we have a constant a equal 10, and then constant integer a equal 10, and then we write a equal 5, right? If you run it, it throws error because it's the error is assignment of read-only variable a. That means a is a constant. Constant means something that cannot be manipulated, something that cannot be changed, right? That means it's read-only. It only allows the user to read it. So we cannot update the value of it. If we are trying to update it, the compiler throws error, right? So it throws error now. So if you define it as integer constant, it's allowed as well. This is also allowed. So sometimes if we are passing a variable, if you are passing a, so if our function is accepting a reference variable, right? For example, n, and then we want to make sure that this function won't update the value inside, won't update the value of n, right? Then we can write a constant to make sure that the value of n won't be changed. Why would we need to make sure that this value of n won't be changed? So it's because that, for example, if you are the caller of this function, inside the main is the caller of this function square, right? It is calling square function, right? And it passing the number, a number. But then maybe main actually doesn't want this square to update the value of number. It wants to make sure that square doesn't update the value of this number. Maybe number will be used later as well. And in our later code, we're expecting this number to be the same as what we initialize it to be, right? We want to make sure that this square doesn't manipulate the data of this number, right? So inside our square function, we can define this pass by reference, this reference variable as a constant. This tells the main that, oh, we won't change the data of n, we won't change the value of it. So you can use it, so they can pass in the n, you can just pass in the n and expect it to remain the same after the function is run, right? So this is all about reference. And let's have a quick recap. So reference basically is to create an alias name for another variable. And when you are declaring a reference, you need to assign a variable to it at the same time. And if we manipulate the data of the reference, it manipulates the data of the variable at the same time. If we have a function and we want to, and we are accepting a few parameters, and we want these parameters to be passed by reference. So in this case, when we define our variables, we can write an n in front of the variable name, like NA and NB. So that means our function is accepting a reference. So the benefits of pass by reference is that it saves memory space, and then it can manipulate the data of, it can manipulate data that is being passed in. Also, it introduced a special keyword called constant. So this const make sure that we cannot change the data of the variable. So when the caller is calling our function, it is being ensured that the data they are passing in won't be changed. And this is all about pointers and reference. So we'll go through some of the exercises together later. But then before that, we'll continue on string processing. So the next lecture we are going to talk about is string processing. So what is a string? String is basically a sequence of characters. It can be any kind of characters like Chinese characters, English characters, or some special symbols. So for example, this is a sequence of characters. These are also a sequence of characters, right? It can be a person's name, a song, or a paragraph. So in C is a language that came before C++, is the predecessor of C++. In C, we use character array to store a string. So, but in C++, we actually use a special object type called string. So string has more functionalities and it is more powerful. So in C++, usually we use string to store a sequence of characters. So it can replace, it can use be replace the character array in C. Previously, actually, we have introduced character array. So character array is that we define an array and this array has a type of character type, right? This is character array. So what's the smallest unit of a text or a string? So it's a character, it's char, char. So in C++, char is also a type. It's also a variable type. It is like integer, like float, like double or long. These are all these are all different value data types, right? So char character is also one of the types. So we can define a character at like char c equal a character a. So our character have to be wrapped in between a single quote. This means our character is a. So the memory space consumed by this character is a byte, 1 byte. And we can read it as character. Char, we can read it as character. And it can store some simple character on it actually. You can store some English characters or some symbols like 1, 2, 3, or a, or at, or dash. So char actually is using the ASCII encoding system. So in ASCII encoding system, each character is each character has its own integer. It's mapped to an integer. So actually we have introduced the ASCII previously. ASCII code. So these are all the ASCII codes. There are 128 ASCII code, and each ASCII code, for example, each ASCII character, for example, capital letter A, can be translated into a number like 65. In decimal, it's 65. And for example, 0 can be translated into 48. For example, small letter A can be translated into 97. So this is a character type, right? This table are all the supported character type. You see, as you can see inside this ASCII codes table, there is no support for like English, there are no support for Chinese words or other or Japanese word or other kind of other languages characters. So it's quite limited. So if you print out a integer a, it should print out 97. We can try it by ourselves. Here we print out. So it prints out 97 because character can be translated into their ASCII number. So in this case, this ASCII number is 97. So how about capital letter A? So here capital letter A is 65. So we can expect it to be 65, right? It's 65. So other than this visible character, this ASCII codes also including some uh not visible one, like some control character. For example, \0. \0 means the end of the string, the end of a character array. So, or \t. \t means a tab, right? In your editor, you type a tab. \n means enter, means another line, changing to another line. So we can try it by ourselves as well. See, \n. So this prints out 10. So there's an exercise over here. I think we can go through it later in the exercise session. So we'll go through it together in the exercise session for this. Oh, so if a user is entering a character, so please write a program to verify whether this is a small letter character or a capital letter character, or is it a number? How can we do so? So if we read in a character, we actually can check if our character is larger equal to A or and smaller equal to Z. In this case, our character is a small letter character. Also, we can write A as 97 and the small letter Z as 122. These two serve the same purpose. They have the same outcome. These are both valid code. And then to check whether this character is a capital letter character, you can check whether it is greater than capital letter A and at the same time less or equal to capital letter Z. So if this is matched, that means this is a capital letter character. And also, we can translate this capital letter A into its ASCII number. Its ASCII number is 65 and Z is 90. So both of these are valid. Also, we want to check whether this is a number character, right? We want to check whether this is a number character. So we can check whether C is greater than character 0 and at the same time smaller than character 9. So bear in mind that we are checking whether C is greater than the character 0, not whether C is greater than 0. Like, we're not checking whether C is greater than number 0. This is different, right? Because C is of character type. So we need to check it with character type as well. Because character 0 in ASCII code, if we translate it into integer in ASCII code, character 0 is 48 as a value of 48. So we shouldn't check whether C is greater than 0. We have to check whether C is greater than character 0. So this is our code overall. We read in a number C, a character C, and then we check. We can try it by ourselves. So I pass in 4. So this is a number. I pass in T. is small letter character. How about Y? It's capital letter character. See? So this means our code works. How about if I change A into A is 97 until 122. 97 until 122. And for capital letter, 65 until 90. 65 until 90. And for number, 48 until 57. 48 until 57. So if I enter 0, it's number 1, it's number 6, number 9, it's a number as well. How about A? Is a small letter number character. A is a capital letter character. Well, Z is a small letter character. Capital letter Z is a capital letter character. About T, capital letter character. Y, small letter character. So that means comparing with integer number works as well, as long as this is an ASCII number. So the ASCII number can be referred here in the table. You can just search online for any ASCII table. And then let's talk about character array. Actually, we have introduced character array already in, I think, a lecture long ago. So this is how we define a character array. We define an array and then of character type, and then we initialize it. And while we are initialize it, the end of the string, the end of the character array have to be \0. This is to tell the compiler that this is the end of our string. This is very important. So remember to include this \0 at the end. Also, we don't have to initialize it with a value. So the compiler will calculate it automatically. Another way to initialize a character array is to just quote it in between a double quote. This is a string. Is to initialize it in a string format. So the previous one, you see our character is in a single quote. So single quote means it's a character, but double string means it's a string. Double quote means the content inside is a string. So this is simpler to write. And then it automatically add the \0 at the end of our string. So I would say this is a better way to initialize a character array. And there are many methods to initialize a character array. Like for the first one, we are not initialize it with a value. The second one, we are telling the length explicitly. And then for a third one, we initialize it with a string, but without a length. The fourth one, we initialize it with a string and a length. And the fifth one, we didn't write the equal sign at all. So all of these 5 are valid. So as you can see, character array is actually not easy to use. It's harder to work with. So, and they have a lot of restriction, like they don't store Chinese character, English character. So in C++, we have something called string. So string is something more powerful with more functionalities. And it makes our life easier if we use it. So string is defined in its own library package. It's called a string package. So if you want to use the string functionalities, we want to use anything related to string, we need to include it in the top of our program. We need to include it like this, include string. So that means we are importing those functions already written by others. So that those functions related to string, we are importing these functions. So inside this standard library, this string library, it allows us to like construct a string object. And then for these string objects, there are a lot of useful functionalities to first to use. So how can we create a string, right? We create a string with this format, string, and then your string name, and then equal to a string. Let's try it by ourselves. String s1 equal ABC. And then we print out s1. Right, ABC will be printed out. Also, we can define it, the string, as a pointer type, right? So this is allowed as well. So that means initially we are not going to initialize the value for it. We will initialize a value for it later. So string is like a data type. Remember previously when we initialize a pointer, we need to give it a data type, right? Like integer, float, or long. So for this case, we give it a data type of string. So our pointer can have a data type of string as well. That means string is actually a data type. And then there is something called constructor. So what is a constructor? Constructor is for you, so when we are creating a string object, the constructor will be called, constructor is also a function. It's the first function that will be called when we are creating an object. So this is called constructor. The default constructor is string, and then there's another constructor, string, and then allow you to pass in another string. And there's another kind of, there are many types of constructor. We'll take a look at some of the examples. So the examples are here. So in this case, this is the default constructor. We create string s1 and we initialize it with 1, 2, 3. And then there is another type of constructor. So for this case, we have a string s1. So we pass in this, when we creating this variable string with a name called s2, and then we write this parenthesis, and then inside the parenthesis we pass in s1. That means s2 will be initialized with the value of s1. So s2 will have a value of s1. Also, there is a substring constructor. What does this substring constructor do? It's like, if we are passing in s1, right? We are replicating the data in s1 into s2. But then let's say we don't want the full string of s1. We want a substring of it. So for this case, we can write so the position, the starting position we want, and then the length of the string we want. So in this case, we say the starting position is that you want is 1. And then the length of it is also 1. So S3 will get a substring from 1 to 3. Also, this constructor support to be passed in a character type, character array, to initialize our S4 with character array. So let's say we have a character array with a value of AJK. So later, when we are creating a string, we can initialize our string with this value inside this character array. And we can just pass in our character array here when we are initializing our string. So these are some examples to initialize our string. And we'll talk more about this. We'll continue to talk about the string, this thing about string next week, and we'll go through some more examples, and I will demonstrate it in the code editor in our platform as well. So now let's take a short break for 5 minutes, and later at 10:06, we'll start to go through some exercises. So see you guys later. So let's go through some of the exercises together for reference. So given an integer called weight, create an alias name for it called W and print out the value inside W. So for these questions, it's a fill in the blank questions. So we can create a reference called W and initialize it with the variable weight. So it prints up and prints up W. Another question, manipulate the data of W into 76 and prints out weight and W and observe the results. So we have weight 67 and we have a reference W initialized as weight and we manipulate W into 76. If we print out both weight and W, they should be both be 76. Yeah. Which one is invalid? Integer a equal 1.1. This is valid. This is valid. Although we are assigning a floating point number to an integer number. So actually the floating point part will be removed, but then still this is a valid one. The compiler won't throw error. But then the second one, a reference initialized as a constant, this is invalid. A reference must always be initialized as a variable. And a reference initialized as a variable, this is valid. And another reference, this one is a reference without initialization. This is invalid. And which one is not valid? We talk about this, we discussed about this already just now in the lecture. So all of the above are valid. They are all correct. So so there's another question. This question is just to run our function and observe the outcome. So as you can see inside our main function, we have integer I and integer j, and then we have a sort function. This sort function is actually accepting parameters through pass by value. This is pass by value, right? If there's an n here, then this is passed by reference. If there's a star here, this is passed by pointer. If there's nothing, then this is passed by value. And if we manipulate a and b here, it doesn't affect the value of I and j here. So if it prints out I and j, it will still be 3 and 7. Now, we need to update this swap function so that it use the pass by reference method and observe the outcome. So now we swap it into NA, we update it into NA and NB, and all the other code remain unchanged. If we run it, you see, now it prints out 7 and 3. That means the changes here in the swap, changes here affects the I and j. The value of I and j are affected. Then let's look at this question. There is an integer, a variable called weights, initialized at 7. And then there's an alias name for it called W. And we assign W as weights plus 1. That means W is now X. 7 plus 1 equal X. And then W plus plus. Then that means W will be 9 now. And we print out weights. Remember, weights and W are the same thing. They point to the same address. So weights should have the same value as W, which is 9. So 9 is the correct answer. So this quiz is asking about if error happen, what is the possible reason? So we have a variable called height, and we create a reference, and this reference is initialized to height. So the error here is very obvious that we didn't initialize the reference right away in the same line. We actually have to initialize it while we are declaring it. So the answer is this. When we are declaring a reference, we need to assign it or initialize it right away. So given the following program, if you want the program to run correctly and to print out num, what should be filled in here? So we have a main function. The main function has a num variable, and they call this, and a print function will be called. So inside this print function, this is passed by reference, and we print out x. So if you want to pass in, a variable to a function that is accepting a reference, we just pass in the variable itself. It's very simple. So just pass in num itself. Yeah, and then that's all. So this is all the exercises on reference. Let's look at string. So the question is asking for character 09, small letter a, capital letter A, and \n, convert into ASCII code and print it out. So that means we are going to print out their ASCII code for 09A and \n. And we can print it out. It's the same answer, 48, 57, 97, 65, 10. And they're asking if we execute A greater than capital letter A, what will be the value? Cout. Let's say cout true. Else print out false. If we run it, so true means small letter A is greater than capital letter A. So 1 is printed out. So 1 is actually true. True, when we print out true is converted into integer, and integer is 1. So that means, why is that so? Because small letter A has a value of 97, but capital letter A has a value of 65. So when we are doing this comparison, small letter a is converted into an integer, 97. Capital letter A is converted into an integer, 65. So 97 is greater than 65, so prints out true. Another question, if a user is entering a capital letter or small letter English character, if capital letter prints out small letter, if small letter 1 prints out the capital letter form. So we can check. First, we have to check whether this is a small letter or capital letter, right? And if it is small letter, we convert it into capital letter. If it is capital letter, we convert it into a small letter. How can we do so? Okay, so we read in a character first. And then for this character, we check whether it's a small letter character. How do we know it's a small letter character? If it is greater equal to A and smaller equal to small letter Z, this is a small letter character. And then we need to convert it into capital letter, right? How can we do so? So we need to check, we need to get the offset of the current character with A, CH minus A. Let's say if CH is, let's say CH is C, CH is C, right? Then what is the distance between C and A? Distance between C and A is 2, right? And then we add these 2 on top of capital letter A plus 2. So we get C. See? Now we convert a small letter c into capital letter C. This is the calculation for it. So on top of A, we add the offset between the character and small letter A. And then also it's the same for this. If character is a capital letter, so character is a capital letter, like let's say C, let's say D, character is capital letter D. And now we need to calculate what is the offset between capital letter D and capital letter A. So capital letter D minus capital letter A, we actually get 3. Why? Because, see, capital letter D has an ASCII code of 6. Its ASCII code is 68 and A is 65. So 68 minus 65 is 3. So we get a 3 here. And then we're going to add this offset on top of the small letter A. So A plus 3, we get D. So this way we convert capital letter into a small letter character. Can run it like A, we get A. If D, we get small letter D. This is the tricks for working with capital letter or small letter and in ASCII code format. So the next question is on string. So we haven't really talked about string yet. So we'll continue this on next week. Just to recap, so this week we have talked about reference, we talked about a special keyword called constant, and then we have do some introduction to a string data type. And next week we'll continue on string data type. We will introduce some more functionalities for it. And so this is all for today's, and stay tuned for next week. And also next week will be our last lecture. So look forward to see you guys. Thank you.